Okay, so we're looking at part B of the investigation. Right, so you should have done the part A bit where you had a square tin plate, right, L by L. So now part B is asking you to do it as a rectangle, and they're suggesting that you do it in a certain ratio. So they've suggested 2:1. Now you could do 3:1, 4:1, 5:1. You could do 3:2 if you want to. I suggest that you choose something 1 to start with, because you have to do at least 2 other ratios. But how do you do that? So I'm going to do a ratio of 10:1, and that means all of you cannot use this ratio. All right? Don't do it. You won't get marks for that. So basically you repeat what you did with part A. So we've got our box and we're saying it's 10:1. So just like in part A, we're cutting out our box here, right? That little section is x by x. So comes in x, comes in x. That's why we've got 10 take 2x as your length. Now you should have explained this really well in part A, but please don't just go, oh, here's the maths for part B. Link it in with part A and say, okay, as we did previously, the length will be this take x, take x. So this is what the length would be, this is what the width would be. So you still need to do a little bit of explanation. Don't just have your mathematics without anything to back it up. All right, so a little bit of expansion. You see you're working. Link it in again with part A. So why are we differentiating? Don't just say word for part A. So differentiate and then you solve. Now, I've done the quad formula here, but you could just say I'm using technology and you can go straight down to the solutions there. And that's, well, what a big surprise. Having a look, you go, yeah, okay, big deal. Then you have to do another rectangle that is also in the ratio of 10:1 because you want to do or look for patterns. So I've chosen 5:10. You could have done 4:40, 3:30, etc. Right, but you want to do it in the same ratio to see if you can find a pattern. So hopefully you can follow again, same deal, 50 take 2x, 5 take 2x times x is your length, your width, your depth. You expand, you differentiate, right, and you get your solutions. So what you now need to do is look and see, is there anything common? What do we notice about them? And you go, well, the first thing that we can notice, might be the second for you, but for me, the first thing is I've got root 91 underneath the square root. Obviously you should do third one to see if it's just freaky for 2 or is it always going to be that. So do a third one and see if you also get root 91 and then you can see that's something that's common. I then look at the first term here, the 11. Here it's 55 and you can probably see it better here that first term is 50 plus 5. Well, is that what happens with that first one? Well, what a surprise. 10 plus 1, it is indeed that 11. Okay? They're both divisible by 6. And to cap it off, here there's a 1 in front of the 91 and that just happens to be the width. And here there's a 5 in front of the root 91 and that also is the width. So you're going to look for any similarities that you have. You are going to state those similarities and make a conjecture. Okay, so for this one, I could write it down and say that this value here is going to be the length plus the width. Now it's up to you. You're going to call it L and W or you're going to say R and S. Okay, so the X solution will be the R value because I would be saying right at the beginning if that's my R and that's my S. And this is when we're in the ratio. Well, actually, this has to be when we're in the ratio of what did we say our ratio was? Stuffing up a little bit there, got 101 things going on. Okay, 10:1. So for the ratio, 10:1, in other words, 10R is to R. All right, can we pop down what this is? So when R for this one, when R was 5, what did we have? We had, I guess you could say 10R plus R That's 11r times 5. I don't know, up to you. You could just say it's the length plus the width and so on. So come up with a little bit of a conjecture. I don't really know how they got the 91 from 50 and 5 or from 10 and 1. You can see if you can come up. It's always going to be divisible by 6. So make that sort of, jot down your patterns. Then it's time, well, can we prove or come up with the fact that we have this pattern? So now, instead of just saying it's 50 and 5 or 40 and 4 and so on, we're saying that the length is 10r and therefore the width is r because it's in that ratio 10 is to 1. And we go through the same process now, but instead of 50 and 5, you know, we've got 10r and r. So can you expand with letters as well as numbers? So do your expansion. You should get this. You differentiate. The big thing to notice is that when we've got 10r squared, that is just a number. So imagine if you had 5x, what is the derivative of 5x? Well, the derivative of 5x is just 5. So that's why down here I've just got 10r squared. So check that, check your derivative. We've then got our quadratic, which we have to solve. So we pop it into our quadratic formula. Coefficient of x is minus 44r. So away we go. We're putting it into our quad formula, which we should know by now. So minus b, so minus 44r. So we've got 44r plus or minus the square root of 44r squared, 44r all squared minus 4 times, and some of you might be going, she's forgot the minus. Well, when I square a negative, I know I get a positive. So 4 times 12 times 10 r squared. And 2 times a, so over 24. And some of these numbers should seem really familiar that you've done them and you go, oh my God, you always get these values. Okay, so now we want to simplify. Okay, so we're going to simplify this. We go 44r plus or minus, what's 44 squared? Right, had to go to the calculator for that bit. 100, so we've got r plus or minus, so 1,936 take 480 is 1,456 r squared. And we're simplifying. All right, so we get, pop it into your calculator. What is the square root of, well, the square root of r is just r, and the square root of 1,456, would you believe, is 4, so 4r, root 91. You go, wowza, we've seen that root 91 before, haven't we? So we go down, and we can see we can divide everything here by 4, so that becomes 11r plus or minus r root 91 all over 6. And compare that to what you wrote down as your pattern for your conjecture. All right, your pattern, your conjecture. So does it match? Now, it doesn't have to be that you said it perfectly. What you can now do is you can adjust. Okay? Or you could go back and change and, you know, reword your conjecture if you really wanted to. But it's better off, say, look, I did this first, this is the pattern I saw, but now using mathematics, I was able to prove this. Okay? So this is it when r is in the ratio, when it's 10r is to r. So do make sure that you state your conjecture really, really carefully. Okay? So please, you choose a ratio, you do 3 examples of that ratio, and then you try and prove it. And then you can go even more hardcore, because we can see, instead of you would, and remember you can't do 10 is to 1, so you could do 2 is to 1, you could do 3 is to 1, then maybe try 3 is to 2. So you're going to do, right, a couple of triangles. I said triangles, but you know that I meant rectangles. Okay, so you can do 3 is to 2. But then do another one in that ratio. So keep it, if you want to keep it small numbers, you can go 6 is to 4. Right? Or you could try, I don't know, times 12. So 12 is to 8, and so on. Do everything. See if you get a pattern. You will see, again, you've got similarities with what you're dividing by. It's probably going to be 6 again, right? But this time the square root might be a different value. So you're doing that sort of thing. And then to prove it, you know, can you do a proof? So the third or the last bit, can you prove it when you've got R and S? Okay, so what would be your length if you're cutting out X by X? What's your expression for the length? What's your expression for the width? Put it into your volume formula. Can you expand it? Can you differentiate it and put it into your quad formula? So that's the extension part to the investigation. But please make sure that when you are checking it, oops, we don't want that. Okay, you will have in total 3 different ratios, and you can't just do just 3:2 and not do any more of 3:2. You have to do several of them to see the pattern. So you're going to do repetition, and I'd strongly recommend that you then use your appendix, because you're going to put their repeat calculations, quite frankly. So if we look at this one, I would probably, just to show that you've got the pattern here, right, would I put both of these calculations? Oops, that's not the one I wanted. Sorry, video's going a little bit long now. Would I put both of these calculations in here? Maybe not. Maybe I'd put this one, maybe I put 2 of them and the third one would go on the appendix, but I just want to see and show them. Or I could just put these calculations and then I'd put this solution and my third solution into a table. Tables are fantastic. Make sure that you use them. Okay, so further extension, this is if you got your A+. Prove using principles of calculus one or both of the conjectures you have found in part A. So please, one or both. Most of us have already proved part A. I think if you want that A+, you prove one of them in part B, just like we sort of did over here. But again, that was the 10:1. You would have to do it for yours. And if you could do it for a third one, that would be fantastic. Okay? So hopefully that helps without giving too much away. And of course, you are going to have to make sure you explain all of your mathematics and it's clear. Please make sure that you use tables to display your work, your summary, because that makes it really easy and good for the marker and even for you to summarize and refer to those tables. Alrighty, good luck with all of it.